All right, let's talk about 2-3 multiplying special cases. If we look over on the left here, I can use patterns to multiply binomials. We're going to get some shortcuts here. Basically what that's saying. So let's look at the table that they gave us here. They gave us an x and a y. Then they want us to do x minus y times x plus y, find x squared, y squared, and then subtract those two. So 7 minus 4 is 3. 7 plus 4 is 11, so 3 times 11 is 33. 6 minus 2 is 4. 6 plus 2 is 8. 8 times 4 is 32. And the last one, 3 minus 9 is negative 6. And 3 plus 9 is 12. We multiply out, we get negative 72. Then if we just do the x squared and the y squared, we have 7 squared, 4 squared, 6 squared, 2 squared, 3 squared, 9 squared. And then we find the difference between these two and this. So it's just taking that first term minus the second term. And then hopefully you realize that these are the same as these, which I suppose we'll get to in a second. So copy and complete the table, did that. Describe any patterns you notice. Well, x plus y times x minus y, this column, is the same thing as x squared minus y squared. So that means we can say that x minus y times x plus y is x squared minus y squared. So again, that's our new rule, our new pattern. Now letter C says, try substituting variable expressions of the form 7p and 4q in for x and y. So we'll look over here, we got 7p minus 4q and 7p plus 4q, just a minus and subtraction, just like we were doing up above. Well, 7p times 7p is 49, p squared. Then we do negative 4q times 7p is negative 28p, q. 7p times positive 4q gives us 28pq. So the positive and the negative forms cancel out. And lastly, negative 4q times 4q, 4 times 4 is 16. It is negative, and q times q is q squared. So what is 7p minus 4q times 7p plus 4q? It is that, 49 minus 16 squared. 49p squared, I keep forgetting that. So it's exactly like the formula says. Now, that's when they were different signs. Now determine the square of a binomial. So why is a plus b squared considered a special case for multiplying polynomials? So we have it written out here. A plus b squared is just a plus b times a plus b. That's what squared means. We're going to split this up so we can get a times both of these and b, just like we've done in class. So a times a is, of course, a squared. A times b is ab. B times a is ba or ab. Multiplication, doesn't matter the order you're doing it. And the last one, b times b, is b squared. So our formula is a squared plus 2ab plus b squared. So in other words, that's the first term squared, the a. The last term squared is b squared. And twice the product of the first and last terms. So a times b times 2. And that's how we got that. And they're saying the same thing over in this visual model. If we have a plus b times a plus b, it's kind of like our box method. Except we don't really have all of those diagrams and whatnot. So a times b, a times. So we get a squared, ab, b squared. So yeah, we still get the same thing. A squared, b squared. And these two give us 2ab. That's what we have here. So it's the same thing, except they're dealing with algebra tiles. So here is our pattern and what we need to know. A plus b squared is a squared plus 2ab plus b squared. Now, quite honestly, you could just multiply it out like normal. do your 5x minus 3 times your 5x minus 3 in this next example. Or we use the pattern. The first is the first term squared. So 5x squared is a 25x squared. Now it's 2 times a times b. So that would be 2 times a times b. And then lastly, negative 3 squared is a positive 9. So that's what they're writing down here. Then we multiply out 2 times 5x times negative 3, we get negative 30x, and everything else is the same. Could we do it the long way? Yeah, of course. We did the same exact thing. We are not going to do this part because it's weird and it's not the best way to do any multiplication. So find each product. Again, we know that a plus b squared equals a squared plus 2ab plus b squared. Well, it also works for minuses. So a minus b squared is a squared minus 2ab plus b squared. So the only thing that's different when we square a binomial is if we have a plus sign or a minus sign. Here we have a minus sign. So that will be a, that will be b. So a squared, that's 3x squared, minus 2 times a times b, and then plus b squared. So now we just have to simplify it. 3x squared, we square the 3, we square the x. Minus 2 times 3x times negative 4. Negative 2 times 3x is negative 6x. Plus negative 4 is a positive 24x. Whoop, where'd my x go? And then lastly, negative 14, or negative 4 squared is a plus 16. Again, it would have been the same as if you did x minus 4 times 3x minus 4. Which way's quicker? I'm not sure, but whatever you're better at, I suppose. So this is kind of getting into what we just did on the product of a sum and a difference. So what is the product? A plus b times a minus b. Exactly what we're just, oh no, not quite the same because it's not a square. One's a plus, one's a minus. So if we're going to multiply them together, as we do here, it'll be a times a minus b and b times a minus b. So we distribute those terms. A times a is a squared. A times a negative b is negative ab. B times a is ba. And b times negative b is negative b squared. Now we should know, again, that negative ab is the same thing as ba. So the ab's cancel out. We're just left with a squared minus b squared. And our pattern is that we have the first term squared and the last term squared. And something they don't mention here, it's going to be subtraction in between them. Always. When we're doing the difference, well, here we go into it. The product of two binomials in the form a plus b times a minus b is a squared minus b squared, where we have a difference, a minus sign, because difference means subtraction, and we have the two squares, a squared and b squared. This is called the difference of two squares. This is super important for what we're doing in the upcoming chapters as well. So, what is the product of 5x plus 7 and 5x minus 7? Doesn't meet the criteria as a plus b and a minus b? Of course. We add in the first one, subtract them in the second one. So, using our formula, I guess that's what they're kind of doing. So, 5x plus 7 times 5x minus 7. We get the a term squared. 5x squared is 25x squared. Minus, and then we do 7 times 7 squared, which is 49. So this is what we get when we multiply those two binomials with a different symbol, the different sign. And we could have done it the long way as well. But if we see the pattern, it's much, much quicker to do that. Again, we're not going to do that type of problem. All right, and the last thing, not the last thing, we'll try the word problem. So here, find the product. Remember, a minus b times a plus b is just b squared minus b squared. So in this case, 2x is a and 4 is b. So it is a squared minus, always, we're doing the difference of two squares, and b squared is 4 squared. So we multiply that out. 2x squared is a 4x squared. And of course, 4x squared, or 4 squared is 16. So that's what we're looking at for that. Is it quicker to do it that way? Yes. Can you write it all out? That's fine. All right, now we have a picture. A graphic designer is developing images for icons. The square pixelated image is placed inside a border that is 2 pixels wide on all sides. If the area of the border of the image is 176 square pixels, what is the area of the image? Okay, so first what we need to realize, and it's kind of hard to read, that the dimension of the white part to the white part is x. We're just saying that the width or the height, they're the same thing in a square, so we have x here, we have x here. But if we want the area of the whole thing, we want that red part with us. Well, there's 2 pixels here, 2 here, so whatever x was, plus 2 is what our height is, and really our width, if we're talking about the whole picture. So, we want to find the area of the image and the border, and that is x plus 4 squared. So, total area, it's x plus 4 squared, because it's length times width, minus the inside stuff. We just want to find the area of the border. We don't care about that middle image. So the area of the image is x times x, or x squared, because we're just using from here to here if we're just talking about the image. So we have x plus 4 squared minus that x squared that middle picture represents. So let's see. The whole thing is our total area. Area of the image is the inside area of the picture. Don't know what that is. And then the area of the border. We know that x plus 4 squared is going to be the area of the whole thing. We're going to subtract off the image, the white part, with whatever symbol that is in the middle, and it should equal 176. So we have x plus 4 squared minus x squared equals 176. There's a couple different things you could do. First, they did x plus 4 squared. Did they use the shortcut to give us x squared plus 2 times 4 times x plus 4 squared? Did they? I don't know. It doesn't matter. You could have multiplied it out twice. Done x plus 4 times x plus 4. It doesn't matter. So either way, we get x squared plus 8x plus 16 minus that x squared still equals 176. Well, we combine it like terms. X squared and negative x squared cancel out. All we have left is 8x plus 16 equals 176. Of course, we subtract 16. And then we divide by 8. So x equals 20. So the image, so that's just of the image. The image will be 20 pixels by 20 pixels. The area of the image is 20 times 20, or 400 square pixels. Where we can use it in word problems, perimeter and area and that kind of thing. So we're looking at two things. Something squared, a binomial squared, or really, I guess, One's a positive, one's a negative, but other than that, they're the same terms. So it results in the difference of two squares. So our patterns are as follows. If we are talking about a plus b squared, or even a minus b squared, we have the same thing. Of course, the only difference is the plus and the minus. Now we're talking about, this. We remember that it's just the first term squared and the second term squared. It's the difference of two squares. And here we can just see some more examples. X plus 4 squared is x plus 4 times x plus 4. If we use our shortcut, it would be x squared plus 2 times 4 times x plus 4 squared. So that would be x squared plus 8x plus 16. We get the same place. Is it quicker? I don't know. Is it better? Not really. Just different. Then we do x minus 7 times x plus 7. Again, this should be x squared minus 7 squared. X squared is x squared. 7 squared is 49, and it is subtraction. Or you could multiply this out. X squared minus 7x plus 7x minus 49. Those x terms cancel out. We're just left with x squared minus 49. And that's really all we're doing when we do these special cases. If the special cases are confusing to you, forget about them and just do it by hand. Do it the slightly longer way.